Hey guys, we are looking at this problem. So in each test case, we are given n, which is 3 in this case, and m, which is 5 in this case. And 3 is the length of the following array, which is 4 to 1. This is array A, right? And we need to find array B with same length, right? And this array B need to satisfy this condition, which is GCD B1 equals to A1, GCD B1 and B2 equals to A2, and GCD B1 till BI equals to AI, right? And all these numbers in B must smaller than n, which is 5 in this case. And we need to find all the possible array B and count them and output the total number of possible array B. So how can we solve this problem? The first step is to transform the equations for a bit. So obviously, GCD B1 equals to B1. So A1 equals to B1. So we can swap these equations B1 out so that we get GCD A1 B2, right? And we can do the same. AI equals to GCD. All the numbers before it equal the GCD of all the numbers before BI equals to AI minus 1, right? And then BI here. So as we can see, when we choose BI, it is totally irrelevant to B1 and B2, right? All that matters is AI minus 1 and AI, and both of these two numbers are known. So when we choose BI, it doesn't matter what we choose BA1, B2 before, right? That is a great observation, which means we can calculate the total number by multiply the number of B and multiply by the number of B2 all the way to Bn, right? So the problem transformed into how do we calculate the number of options for BI, right? So how do we solve this problem? So this problem is, as we said before, this problem is equivalent to find the possible values of BI, right? So basically, we can do some transformation on this equation as well. So AI is the GCD of AI minus 1 and BI. So these two numbers are the multiply of AI. So we can move AI to the right side, which means when we divide both sides by AI, then we get 1 to the left side, and we get AI minus 1, AI, and BI, AI, right? So this guy is a known value because both of AI and AI minus 1 are known. And this guy is a unknown value. And this guy should be smaller than m divided by AI, right? And this guy is a known value. And this guy should be equal to 1. So the problem is equivalent to calculate the total number of possible x that is coprime against the d, which is a known value. So how do we solve this problem? So we can break d down into factors, right? And the power of each vectors are irrelevant. So let's say it breaks down into 3 prime vectors, and we need to calculate the number of coprimes that are smaller than m divided by AI, right? So we can use inclusive and exclusive theory here. So let's say this rectangle has all the numbers that is smaller than this guy. And there are 3 sets. Which means 3 circles inside the rectangle. One circle is all the numbers that is a multiply of f1, all the multiplies of f2, and all the multiplies of f3. And this part, this blank part, is what we want to count. This part is not any multiply of these 3 prime vectors. That means they are the coprimes of D, right? And how do we count those? So basically, we calculate the number of all numbers minus the number of f1's multiplies, and multiply and minus the number of multiply of f2's, etc., and plus the number of numbers that both that are multiplies multipliers of f1 multiplied by f2. Is that right? We need to find the numbers that are both multipliers of f1 and f2. That is it, right? And we need to add the number of numbers that are both that are multipliers of both f2 and f3, etc. And we minus the numbers that are multipliers of both f1, f2, and f3, right? And that is it. So that is how can we find the number of coprimes of D, right? And that's it. That's how we solve this problem. Thanks for watching.